Okay, let's get into this. We're looking at something pretty crucial in programming. Testing code that, well, doesn't finish right away.
Right? Asynchronous code,
Hmm.
like fetching data, reading files,
Hmm?
stuff that takes a moment.
Exactly. And the big challenge is your test might just run straight through and finish before that async task is actually done.
Yeah, and then your test fails, but not really for the right reason. It just didn't wait. So you need your test framework to pause somehow. It needs to wait for the result before checking anything.
And we're going to explore how frameworks manage this, looking at callbacks, then promises, and finally async await. It's super important for writing tests that, actually work for real-world code.
Let's start with the older way, callbacks. You often see this special function, usually is called done, passed into your test function.
Yeah, the done callback. Seems a bit manual these days, maybe.
It is, definitely. You start your async operation, and then inside the callback from that operation, that's where you put your assertions. And then, the key part, you must call done.
So you look at that fetch data callback example structure we talked about. The assertion happens inside the function that fetch data callback calls, and then done gets called.
Exactly.
Okay, but what if something breaks? Like an error happens in the async part or in that callback, and done just never gets called.
That's the tricky part. The test framework won't wait forever. It'll eventually hit a timeout limit and fail the test.
Which tells you something went wrong.
Right, it tells you it timed out, which points to the async operation not completing or done not being called, but it doesn't always pinpoint why or where it broke down. That timeout error can sometimes be a bit vague.
Okay, so that's callbacks with the manual done. Things got better with promises, though, right?
Oh, definitely. Promises are great for this. The key idea is simple. Instead of dealing with done, your test function just returns the promise.
It just returns it, and the framework understands.
Yep. Frameworks like Jest, for example, they know what to do with a return promise. They automatically wait for that promise to either resolve, succeed, or reject, fail.
So for something like that fetch data promise function, you just call it in your test and return whatever it gives back. The framework handles the waiting part itself.
Precisely. If you expect it to succeed, you chain a job semita onto that return promise. Inside the dot, you get the data, you run your checks, your assertions.
And the framework waits for that then, block to complete. Okay, what if you expect to fail? Like the promise should reject.
Then you chain a dot catch instead of, or sometimes after a dot then. Inside the dot catch, you can check if the error you got is the one you expected. It's much clearer than just getting a timeout.
That makes a lot more sense, yeah. Returning the promise feels much more direct.
Okay, now, building on promises, we've got async await. People often say this makes async code look almost synchronous. How does that affect testing?
Async await usually leads to the cleanest, most readable tests for async stuff. You just mark your test function itself with the async keyword.
Okay.
And then inside the test, whenever you call a function that returns a promise, you put the await keyword in front of it. And await basically just pauses the test right there until the promise settles one way or the other.
Exactly that. It waits for the promise to resolve, gets the value, and then the test continues on the next line. You can assign the result to a variable and then run assertions on it, just like you would with synchronous code. It reads very naturally.
Okay, that sounds straightforward for successful promises. But what about testing rejections with async await? How do you await something that's supposed to throw an error?
Good question. One common way, like in that fetch or promise example pattern, is using a standard try.catch block. You await the promise call inside the try. If it rejects, it throws an error, the catch block catches it, and inside the catch, you assert that you got the error you expected.
Right, the classic try.catch. Or I think I've seen special matchers in frameworks too, something like await expect and then maybe dot rejects.
Absolutely. That's often even cleaner, especially if you only care that it rejects. Frameworks often provide something like expect my promise call dot rejects dot to throw error message. It explicitly states the intent. I expect this promise to reject with this specific error.
Yeah, that feels very clear.
It really is. So the main point is modern testing tools handle async code really well now, especially promises and async await. Once you know these patterns, writing these tests becomes much less daunting.
So wrapping up, we've seen these different ways testing frameworks let you handle async tests. Callbacks with done, which is less common now, returning promises for the framework to handle, and using async await, which often reads the best.
Yeah, and the fundamental thing, no matter the method, is making sure the test waits. It has to wait for the asynchronous operation to actually finish before it checks the outcome.
What's interesting here, looking back, is how the style of your application's async code callbacks, promises, Async directly mirrors the style you use in your tests. Which kind of leads to a final thought for you, the listener. Think about how your choice between these asynchronous patterns, callbacks, promises, async doesn't just change how you write the code itself, or even just the tests. How might it influence the overall structure, the maintainability, maybe even the testability of your entire application? Is choosing a pattern that's easy to test maybe leading you to better code design overall, something to reflect on?